Okay, so you have to recognize that this is an absolute value function. So you have your parent function in your mind. You know what that looks like. But this function f of x, what do I do to the parent function? What am I doing to it in terms of shifting? What am I doing to it?
It's a vertical shift.
It's a vertical shift. Which way?
Up two.
Up 2. Okay? It's a vertical shift up 2. So if you recall, the key points you have to use on the parent function. Remember your key points. So for the absolute value of x, which you need, for the absolute value of x, what are the key points that you're going to use?
0, 0.
0, 0. What else?
1, 1.
1, 1. 2, 2, and so on, right? On this side, what are you going to use?
Negative
1, 1.
Negative 2.
Negative 2, 2. And so on. Okay? So that is your, oops, why is it?
Got a question for you. When we're doing the homework assignments, we don't have to graph both of them on there, do we?
Whatever the direction says. Whatever the direction says. Just not. Okay. So this is your parent function, correct?
Mm-hmm.
All right. So I'm trying. I got to fold it like that because on the video it's there's a lot of glare, so I got to fold it. All right. So there's your parent function. Now what I want to do. So this is going to be this right here is absolute value of x. Okay. What I'm trying to graph though is, what was it? Absolute value of x plus 2?
Mm-hmm.
All right, so absolute value of x plus 2. I'm not sure why I hate that glare. So absolute value, that doesn't help me. So absolute value of x plus 2, correct? Okay. All right. So what does this right here? Oops, sorry, wrong one. Excuse me. That. All right. So what does this tell me to do to this?
Shift everything up to.
Shift everything up to. So 1, 2. So that's what the graph should look like. Okay. That's what it should look like. Y'all agree?
Mm-hmm.
All right. So then when you do it by, now remember I'm using transparency here. So what you would do though is you would do your parent function. 0, 0, what else?
1, 1.
1, 1, 2, 2, negative 1, 1, negative 2, 2. Right?
Mm-hmm.
That's the way you would do it on paper. I'm sorry? You what now?
It's super blurry. I can't.
Because she's sitting to the side, it's super blurry for her.
Like when you change the light, I can't.
Okay.
There.
All right. Okay. So then what does this tell me to do to this, to these points?
Up to.
Move it up 2. So this should go 1, 2. This should go 1, 2. This should go 1, 2, 1, 2, and so on, right? That's what you would show. So then there's your graph. Now make sure you tell me that this is absolute value x plus 2 here, and this is what? Absolute value of x. All right, so that's what you'd show. Any questions? And then remember the transparency. When I did this, so the blue was the parent function, right? Mm-hmm. And then the red tells me to do what to the blue? Move it up 2. And so that's what it should get. Okay? So any questions? All right. So let's look at this one now. Suppose I want to graph f of x equal the absolute value of x plus 5. So f of x equal the absolute value of x plus 5. So you got to know what kind of shift this is.
That's a vertical shift.
That is not a vertical shift. We just talked about a vertical shift. The 5's inside. It's not outside. If it's inside, it's what kind of shift? Horizontal. You see how some of you are still not remembering this. You better do whatever you have to do to remember this. It's a horizontal shift. Now, with horizontal shift, it's counterintuitive of what you would think. Like the vertical shift is easy to remember. I graph the parent function and I shift every point up 2 units, plus 2. Here, this says I graph the parent function. I graph absolute value of x, and I shift it which way?
2 to the left.
Five.
5 to the left.
5 to the left. So shift it 5 units to the left. So it's not, don't look at that plus 5. Don't look at that plus 5 and think 5 units to the right. It's counterintuitive what you would think. And you're going to understand why in the next course. But it's counterintuitive. So it's 5 units to the left. So remember, a horizontal shift, you do the opposite of what you would think. Okay? So in other words, if I were to put this graph again, this is my parent function, right? How do I move it? 5 to the left. So when I finally graph what I want to graph, this is what it's going to look like. So notice I'm going 5 units to the left. 1, 2, 3, 4, 5. This is where it eventually will be. Okay? That's where it will be. All right. So let's graph the parent function. 0, 0. So your question about do I need both? Yes.
I don't think the instruction said that, though.
Okay, now it does.
I gotta go back and-
Because I want to make sure you see that you're actually moving it to the left. So go ahead and put both of them. It's no big deal. You can
All
do
I
it.
did was I wrote 2 T-tables.
That's had nothing to do with T-tables. You didn't need T-tables. You know, I want you to use the idea of shifting.
All right.
All right, let's go back and redo that. So 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. So then you graph the parent function. Okay? Now, according to this, how do I move all these points? 5 to the left. Don't use any T-tables. I want you to use the idea of shifting, because that's what you're going to do next semester anyway. You're going to use the idea of shifting. So every point, to this point here, I'm going to move which way?
Left.
To the left, how many?
5.
1, 2, 3, 4, 5. This point here?
5.
5. 1, 2, 3, 4, 5. The vertex, that's your vertex, right? Vertex, move it which way?
5.
5. 1, 2, 3, 4, 5. This point here?
5.
1, 2, 3, 4, 5. And finally, this point here?
5 to the left.
1, 2, 3, 4, 5. And then you graph it, and that's what you get. All right, so this is absolute value of x, and this right here is which one? Absolute value of x plus 5?
Mm-hmm.
And then let's check it. Let's see if that does make sense. So I'm going to go back. And so what do I do to the blue graph?
Move it over to the left.
Move it to the left 5. 1, 2, 3, 4, 5. And it overlaps the other one. Okay? All right, any questions on that? Okay. All right, so let's look at this one now. Suppose we had all right, suppose we had this. All right, suppose you want to graph f of x equal negative absolute value of x. Negative absolute value of x. So, what does negative out in front do to the parent function? What does that negative in front here do to that parent function?
Does it invert it?
Reflects it about the x-axis.
So instead of a V, it'd be like a triangle.
No. Instead of going up, it will do what? Go down. It will do this.
A triangle.
All right, so instead of going up, it's going to go down. All right? Okay, and it kind of makes sense because if we did talk about this in terms of a T-table, which I don't want you to, I want you to use the idea of transformations. Here's why. See, all these, when it reflects down, all these y values are what kind of numbers that I'm pointing to right here.
Maybe.
They're all negative, except for this one, which is what?
0, 0.
0. So when x is 0, what's negative absolute value of 0?
Negative 0.
or
Zero.
0. If x is 1, what's negative absolute value of 1?
Negative one.
-1. See that -1 right here? You can't. See that -1 right here?
Mhm.
If x is -2, what's negative absolute value of -2? What's absolute value of -2?
Two.
2. So this is a negative what?
Two.
2. So when x is -2, my y value is what? -2. Kind of makes sense because look, -2, -2. Okay? So all these y values, except for this one, all these y values would be what kind of number? Negative. All right. So basically what's happening is that when you grab the parent function and there's a reflection, then all you're doing to these y coordinates is taking the opposite. So this point here, which is 1, 1, becomes 1 what? -1. This point here, which is 2, 2, becomes 2, -2. 3, 3 becomes 3, -3, and so on. Okay? So basically you're going to do this. You're going to graph the parent function. Looks like this. Graph the parent function. So that's absolute value of x. And then to graph negative absolute value of x, the y coordinates, you're just going to change the sign of. So 0, 0 stays 0, 0, right?
Mhm.
So that's still your vertex. 1, 1 becomes 1,
Negative one.
-1. 2, 2 becomes 2,
Negative
-2. So you're just reflecting it about the what?
X.
X-axis. So notice the reflection. So notice this. See this distance here that's above the x-axis? See this point that's above the x-axis? You all agree it's 1 unit above?
Mhm.
When I reflect it, it's 1 unit where?
Below.
Below. This point here, that's 2 units above the x-axis. When reflected, it's how many units below? 2. Okay, so same distance, right? So this point here, which is 3 units above, is now 3 units below. So you get this part of the graph. Same thing here. -1, 1 becomes -1, -1. -2, 2 becomes -2, -2, and so on. All right? So this is negative absolute value of x. That's what this one is. So again, notice, here's a parent function. The negative out here talks about the reflection about the x-axis. So when reflected about the x-axis, I get this. Okay? Any questions? All right. So in terms of... Okay. All right. So everybody okay with absolute value now? All right. Let's talk about square root. All right. Square root. Okay. So to do square root, okay, square root of x. So the square root of x is going to be our parent function. So the parent function for the quadratic is x what?
Squared.
Squared. So your parent functions are going to be x squared. And what's the one we just did?
This,
Absolute value of
absolute value.
x. And then now we're doing the other parent function, which is going to be the square root of x. So those are 3 that you need to know here. And then as you go along your course next semester, there'll be some others that you're going to deal with. All right. So let's talk about the square root. So if you have your calculator, you want to take the square root of a negative number. What happens if you take the square root of a negative number on your calculator?
Should be a squared.
So for example,
Well, you'll get
If-
a positive number then, correct?
I don't know. Let's see.
Square root.
So if I take the square root, so square root's, you got to press second x squared to get to it.
The main arrow.
So the square root of, let's say, -4,
You get an error message.
you get an error message. All right, because you cannot take the square root of a negative number. So for example, the square root of 4, what's the square root of 4?
2.
2, because you're asking yourself, what number times itself is my radicand? So what number times itself is 4?
Two.
2, because 2 times 2 is 4. Square root of 9, what's the square root of 9? 3, because 3 times 3 is 9. Square root of 0,
0.
because 0 times 0 is 0. But notice all these numbers that I'm putting in here are positive or 0. So if you ask yourself, what about a negative 4? What real number times itself is negative 4? What do you think? Some people may say negative 2.
But a negative 2 times a negative 2 is a
Positive.
positive.
Exactly. All right, so the square root of a negative 4 is not negative 2. So you're going to learn, in this course, you're going to learn something called imaginary numbers. So it's not a real number, but it's going to be an imaginary number that you're going to need when we get into solving quadratic equations. But square root of a negative 4 is not a real number, and we're only graphing real numbers here. So you cannot take the square root of a negative number. Okay, square root of a negative 4 is not a real number. It's a
Fake number.
it's a complex number, an imaginary number. I tend to call it an imaginary number. That's where you get that I. And remember that I from maybe high school, advanced math.
Math back in the day, you know.
Okay, 2i. All right. So when I graphed this, remember we talked about domain? That was something you had to turn in, domain and range. When I graph this, I've got to look at my domain. So the domain, remember, are the set of x coordinates. So in terms of what I can use for x, what's the smallest real number I can use for x?
0.
0. So when I use a t-table to help us with this, I'm going to start with 0. I can't use any negative number, right? So when I plug in 0 for x, what's the square root of 0?
0.
I get the point 0, 0. If I plug in 1 for x, what's the square root of 1? 1. So I get 1, 1. Now I'm going to use nice numbers for x. Because if I use 2,
Complicated number.
square root of 2 is not a whole number. Square root of 2 is this irrational number. So watch, it looks like this.
It's not a perfect square.
It's not very good. It's not a perfect square. So square root of 2 is this. Oops, I said answer times. Excuse me. Let me redo this. Square root of. Why I keep saying answer?
It's the next one down, I think, when you keep that.
All right, so second square root. Okay, 2. So this is what you get. All right. So it's not a whole number. It's an irrational number. So I'm not going to use 2. I'm going to use nice numbers for x. I'm going to use perfect squares for x. You use the word perfect square. So I'm not going to use 2.
4.
4 is a perfect square. So when I plug in 4, what's the square root of 4?
2.
2. What's the next perfect square beyond 4? 9. Good. What's the square root of 9?
3.
3. And so we'll just use those for right now. So now I'm going to plot those points. I'll plot those points. So I'm going to graph f of x equal square root of x. So 0, 0, 0, 0, 1, 1,
1,
4,
4, 2,
2, 9,
3.
3. Okay? And it's going to look like this with an arrow on this end. Okay? All right, so there's an end point on one side and there's an arrow on the other. Notice the curve. If I turn it around, it looks like half of a what? Parabola. And it kind of makes sense because square root of x, x squared. So it looks like half of a parabola. So that's the shape of it. The shape of it looks like half of a parabola. So here's your square root function. There's your parent function for the square root. Okay? So it's a curve that looks half of a parabola. All right, any questions on that? All right. So let me go ahead and just quickly,
I lost something on there.
what'd you lose?
I don't know, when you started graphing it, I didn't understand it.
I apply the points 1, 1, 0, 0, 4, 2, 9, 3. And I just connected them.
Okay.
All right, 0, 0 is your endpoint because that's what we just talked about. Say the smallest number I can use for x is 0. That's your endpoint. All right, so when I'm going to put that in transparency, and then we're going to talk about, oops. Then we're going to talk about,
Shifting.
yeah. Okay, so you got to know now what the square root function looks like. It's a shape of half a parabola. There's an endpoint and an arrow. Okay? All right, now let's suppose you want to graph this. Suppose I want to graph g of x, which is the square root of x minus 3, let's say. How are you going to graph it?
You would graph it just like that, except you would shift it.
It's outside, so it's gonna be, vertical.
So
Okay,
you'd shift
the
it
number's on the
down-
outside, so it's a
down
vertical
3.
shift.
Yeah.
So you can take the parent function, you're going to shift all those points which way?
Down 3.
Down 3. So basically you're saying you're going to take this right here,
and just
this
go
right here.
with it.
and you're going to go down 3. Notice 1. Just look at this right here, the end point. So I went down 1, I went down another, and I went down another. So that's what your graph looks like. So when you eventually graph it, this is what it looks like. Okay? But that should not be an issue anymore because we talked about square root. We talked about absolute value. We talked about shifting. All you do here is that you're going to take the absolute value, you're going to take the square root function, and you're going to shift it which way? Shift down 3. 3 units. So this point, move it down 3. 1, 2, 3. This point, move it down 3. 1, 2, 3. This point, 1, 2, 3. And this point, 1, 2, 3. And so there's your graph. Do the best you can. Just make it look like it's been shifted down 3. And so again, let's see if it works. Let's see if it works. So I had this, right? And I go down 3. 1, 2, 3. And so that's what I get. Any questions on that? You got it? All right. Now, let's look at one that looked like this now. All right, so let's suppose we had this. Suppose we had f of x equal the square root of x plus 2. Square root of x plus 2. Don't use t-tables because you're really not going to know where the endpoint is. So use shifting. That helps tremendously. And that's what you're going to use next semester anyways, the idea of transformations. So what do I graph first? If I want to graph this, what do I graph first?
The square root of
The
x.
parent function. All right, so you got to remember your key points, those 3 key points. 0, 0. What's the other?
1, 1.
1, 1. What's the other?
4, 2.
4, 2. And what's the other?
9, 3.
9, 3. And so this is what your parent function looks like.
Plus 2 inside of the thing, so it's going to go to the left 2.
All right, so look at where your number is. It's a number on the outside of the square root function. No. So it's not a vertical shift, then it's going to be a what?
Horizontal.
Horizontal. And when you think horizontal, you're going to move left, right, and you see the number 2 here. But you got to remember, is it 2 units to the left or is it 2 units to the right? If it's horizontal, you think counterintuitive of what you see. You see a plus 2, so you're going to do the opposite. So it's 2 units which way? To the left. So you're going to take the square root of x and shift it 2 units which way?
To the left.
To the left. Okay? So in other words, if I were to do this right here, okay, this, I'm going to go to the left, correct?
Mhm.
So 1, 2. That's what it should look like. That's it?
Just like barely over the other one.
Yeah, and the reason is because of the curve. So see how there seems like a lot of space right here compared up here? That's why. All right, so just do the best you can. So you're going to shift it which way?
2 to the left.
So every point moves to the left, right?
Mhm.
1, 2. 1, 2, 1, 2, 1, 2. So there's your graph. Okay, just do the best you can with it. So this would be the square root of x plus 2. Okay? So any question on the absolute value? All right. What if you had this?
Inverse of the
What if you had that?
parent function.
That's you gotta use the words. This is a reflection about the x-axis. Reflection about the x-axis, not an inverse. All right. You're going to talk about inverses in the next course. So it's a reflection about the x-axis. The inverse function is the quadratic function. So the inverse function would be x squared. All right. So the inverse does not mean reflect.
I was thinking of invert.
Say reflect. Say reflect. All right. So what that does is it tells me that if this is my parent function right here, this is my parent function, then I got to do what to this parent function?
Down, shift down.
Nope.
Each of
The what?
the endpoint stays the same in each of the
What I want you to,
points.
what I need for you to be able to say that one phrase. Reflect about the x-axis. The negative out here means to reflect about the x-axis. In other words, instead of looking like this, I'm going to reflect about the x-axis and it's going to look like that. Now it is true that here, except for the endpoint, all my y values are positive. When I reflect about the x-axis, they all become what?
Negative.
That is a true statement. But I need for you to say that this right here means I take the parent function and I reflect it about the x-axis. So take square root of x and reflect about the x-axis. Okay, so you reflect about the x-axis. So when you do the worksheet, you're gonna graph your parent function first. So what's my parent function? What are my key points?
0, 0.
0, 0, 1, 1, 4, 2, and 9, 1, 9, 3, right? There's my parent function. And just like we did the absolute value here, so remember how we said that this point here was 1 unit above, so I go 1 unit below the x-axis. This point here was 2 units above, I go 2 units below. Same idea. So the endpoint's at the origin, so it stays at the origin. But the point 1, 1 becomes what point?
1, -1.
1, -1. The point 4, 2 becomes what point?
4, -2.
4, -2, and the point 9, 3 becomes 9,
-3.
-3. And so,
I mean, essentially, you're just kind of getting at the other half.
yeah.
Obviously, reflected on the x-axis.
That's right.
So you see, it looks like a
Reflect about
parabola.
the x-axis.
See that parabola? All right. So this part though, this part of the graph is what function?
That's
The parent function.
The parent function. This part of the graph is the reflection. So it's a reflection about the x-axis, right? Okay. All right. Any questions? Okay. Now, okay, let's look at this. Okay, so in part A, I'm going to give you part A. So part A is this. So you had this quadratic. So you have x squared minus 2. Here you have x squared plus 3. Absolute value of x minus 1. Absolute value of x plus 4. All of these represent what kind of shifts? Vertical shift, because all the numbers on the outside, right? Okay, so it says graph each function, determine the vertex. So you know what the way I want you to do this. Of course, the directions don't say it, but I need for you to do it this way. So So you're gonna graph your parent function first, right? And then your parent function has that vertex. So whatever it looks like. Let's say, well, you all should know what the parent function looks like. This is your parent function, 3, 9, right? And the same thing here. I didn't do a very good job graphing it. So there's your parent function. So then all these points you plot, are you going to move it what?
Up to.
No,
Down.
down 2. So you go down 2. 1, 2. So here's your new vertex. And so all it says is plot 2 points to the right and 2 points to the left, which you already have by just doing what? Shifting it down 2. All right, so I want you to do the parent function and its shift. Okay? Understand? Okay. So quadratic. So this one is -2. This one's +3. Quadratic on this side. And what's on this side? Absolute value, right? Okay. What's the shape of absolute value? V. It's that shape of a V. Okay. All right. So let me go ahead and give you that. So that's part A. Okay. While that's being passed around, look at this. What kind of shifts is this one right here? Can y'all see it?
Horizontal.
These are horizontal shifts, right? So you can grab the parent function first. You're going to grab the parent function first. And then you're going to do what?
Shifted.
In this case, you're going to shift it to the
Right.
right 3 units. So every point you're going to shift to the right 3 units. Okay? This is what kind of shift?
Horizontal.
Horizontal. So it's a quadratic. Remember that parabola? And it's a shift a certain way. All right, let's look at the back. What kind of graphs are these?
Absolute.
Absolute value. Those are what kind of shifts? Horizontal. What being passed around are what kind of shifts?
Vertical.
Vertical. These are what kind of shifts?
Horizontal.
Horizontal. Okay? Nothing difficult with those. So quadratic, absolute value. All right, so that's this part. Let me give you that. Okay, so let's graph this.
So is part C due on Tuesday?
No.
Okay, Thursday.
Yeah, part C we do Thursday. Okay, so let's graph this. Let's graph f of x equal, let's say, 3x squared. Let's graph f of x equal 3x squared. The grid paper is not, the width of it, the length of it is not big enough to get all these points I need here. So I'm going to do this by hand. Okay, so I'm going to do this using a t-table. Okay? And I'm going to use the same x coordinates as I did for x squared. So what x coordinates did I use for x? 0, 1, -1, and what? 2 and -2. That's what I used. Okay? You can do the same thing. When x is 0, y equals 3 times 0 squared. What's 3 times 0 squared? 0. Okay? When x is 1, I get y equals 3 times 1 squared. 1 squared is what? 1 squared is not 2. What's 1 squared? 1. 1 times 3 is 3. So I get the point 1, 3. When x is -1, I get y equals 3 times -1 squared. What's -1 squared? 1 times 3 is also 3. When x is 2, I get y equals 3 times 2 squared. What's 2 squared? 4 times 3 is 12. When x is -2, what do you think the y value will be? 12 as well. So it's 3 times -2 squared. What's -2 times itself? 4 times 3 is 12. All right, so those are the points I have. Okay. And let me see. I'm going to try and make it fit on here. I don't know if it will. Let me see. I have to extend this. So here's what I'm going to do.
Some of your worksheets, you got all the way up to 15 on the grid.
Okay. All right. So I'm gonna have to extend this. So I'm plotting the point 0, 0, right? Okay, so here's 0, 0. That's and that's gonna be the vertex. 1, 3 is here. See what it looks like? Right here. And then negative 1, 3. So you're going to learn next semester about symmetry. So the parabola is symmetric about, in this case, the y-axis. So next semester, you're going to talk, when you do the shifting, there's other kinds of symmetry. It's not always the y-axis. Then 212. Okay, so I'm going to have to count up here. So 212, so that's 9. Let's see. So that's 9, 10, 11, 12. So 212, let's say, is here. And then there's 2, negative 12, negative 212 as well, right? Negative 212, which is, let's say, here. And so I get something that looks like, I didn't do a very good job with this. Something that looks like this. Okay? All right, so there's your, so this is the graph of 3x squared. Y equals 3x squared. Okay? All right, and so that's all you have to do is just use the t-table for this and then go ahead and graph it. Now next semester though, you're gonna learn about this. You're gonna learn about the idea of stretching and shrinking. Stretching and shrinking. So if I were to graph, just for argument purposes, if I were to graph the parent function, x squared. So remember our key points, 0, 0, what's the other? 1, 1, 2, 2, 4, right? And on this side it was negative 1, 1, negative 2, 4. Remember that? And so this that I'm drawing here is x squared, right? So notice that this 3 in front shrinks it, or should I say it stretches it. It stretches it towards what? It's like taking a rubber band and pulling on it. All right, so stretching it towards the y-axis. Okay? All right, so the 3 is a stretching. So you're going to take the parent function and you're going to stretch it towards the y-axis. So what that means is this. What that means is this. All these y coordinates, you're multiplying by what? 3. So on my parent function, when y was 1 here, what's going to be my new y value? 3. See it? Right here, when y is 4, 4 times 3 is 12. You see it? Okay, so that's what that means. So you can learn about that next semester in terms of stretching and shrinking. All right, but you're going to do it just by using a t-table. That's the way you're going to do this one. All right, now what if you had this? What if you had, let's see. Okay, what if you had f of x equal negative 3x squared? We already know what 3x squared looks like. What do you remember that negative does? Reflects it about the x-axis. Remember that? So we know what 3x squared looks like. The negative 3x squared is a reflection about the x-axis. Just use the t-table. So you know, all you know is that instead of the graph pointing up, it's going to do what? Point down. All right. So use the t-table with these. Now you can, if you want to, you can draw the parent function. Nothing wrong with that. If you want to draw the parent function, you can. 0, 0, 1, 1, and what else?
2, 4.
2, 4. And then negative 1, 1, negative 2, 4, correct? Okay? So there's your parent function. You can do that. And just remember that negative 3 means that you're going to take all those y values on this parent function and multiply by what? Negative 3. So this y value right here is what?
0.
That's your origin. That's your vertex. So, and 0 times negative 3 is still what? 0. This y value is what?
1, 1,
1, 1,
But my y value is what?
1,
1. 1 times negative 3 is
negative.
negative 3. This y value is what?
4,
4 times negative 3 is
negative 12.
negative 12. So it's way down here somewhere. Let's say it's here. Over here, this y value is what?
1,
1?
1.
It's supposed to go through it, but it
I
did.
mean, 1. It's
1.
It's 1.
1 times negative 3 is
negative.
negative 3. This y value is 4. 4 times negative 3 is
Negative 12.
negative 12. And so you get this. You see it? So it's kind of like, I want to show you this. It's this right here, but reflected about the x-axis. All right. So if you want to, it's up to you. It doesn't matter now. But if you want to draw your parent function, just remember that all these y values you're going to multiply by, in this case, negative 3. Then go ahead and do it. If you want to, you can do this instead. You can use a t-table: 0, 1, negative 1, 2, negative 2. But I think it may be quicker for you if you do the parent function and just do those 5 points. All right. But so if you do the t-table, you got to do this now. You got to say, all right, if x is 0, notice how it takes a little bit longer. If x is 0, then this is y equals negative 3 times 0 squared, right? Then you got to remember the order of operations. I got to do exponents first and then multiply.
0, 0.
So that's 0. So I get the point 0, 0.
Negative 3, 0.
Then x is 1. I got y equals negative 3 times 1 squared. 1 squared is what?
1,
1 times negative 3 is
negative 3.
negative 3, which is what we already knew, right?
Mhm.
If x is negative 1, now this is where some of you get messed up because of that negative out here. If x is negative 1, I get y equals negative 3 times negative 1 squared. But you got to remember, negative 1 times itself is 1. 1 times negative 3 is still negative 3. You understand what I'm doing? So it's up to you. It may be better for you, since we've been graphing those parent functions for the other two, to use the parent function and just multiply the y values by this coefficient. Okay? So it's up to you. You get the same thing, right? Whether you use a t-table or use the parent function.
On a test, would you want to see the t-table or the work for it?
It's for the two I just gave you, it will probably say use the idea of shifting. If there's a number in front, I won't say anything. You can just use whatever you want to. Okay? But the first two I definitely will say use shifting for those. Because I need for you to know about shifting, because you're going to need to know that next semester. But this would be a stretching. All right, now let's talk about what if you had this. What if you had f of x equals, let's say, 1/3 x squared. 1/3 x squared. Let's see what that looks like.
Yeah, within in between points.
All right, so watch. Let's say we had this. All right. Okay, so let's do the parent function. Let's do a parent function. So I'm dealing with x squared, right? So what are the key points for the parent function? 0, 0, 1, 1,
2, 4.
2, 4. Negative 1, 1, negative 2, 4. So it looks like this. Okay? All right. So to get my function I want to graph, I'm going to take all those y values and multiply by what?
Third.
1/3. So what's this y value right here?
0.
0 times 1/3 is
0.
0. What's this y value?
1.
1 times 1/3 is
1/3.
1/3. That's right here. What's this y value that I'm pointing to? 4 times 1/3 is 4/3, which is what mixed number? 1 1/3. So that part of the graph looks like this. See it?
Mm-hmm.
Remember the one we did where it was 3x squared? It was inside like this. This one's going to be where? On the outside.
So where is that one? That one's inside
1 1/3.
1 1/3.
4 times a third is 4/3, which is 1 1/3, right? Okay. And over here as well, what's this y value?
-1,
-1 times 1/3 is,
-1/3.
it's not -1, it's +1, right?
Oh.
The y
yeah,
value?
Okay, yeah.
So it's 1/3, so that's about here, right? What's this y value?
4,
We already did that, and what's 4 times a third?
1 1/3.
4/3, which is 1 1/3. So that's about here.
Mhm.
Okay. So remember the one we did here was 3x squared. See how it was being, it's like taking a rubber band and stretching it so it looks skinnier. Okay. This one looks a little bit fatter. All right, so you're actually shrinking it. You're shrinking it towards the x-axis. All right, so one's a stretch, one's a shrink. You have to know those words, but just know that one looks skinnier and the other one looks what? Fatter. So the difference is this. Remember you talked about proper and improper fractions?
Mm-hmm.
Is 1/3 a proper or improper fraction?
Proper.
Proper. So if the coefficient's proper, it's going to look fat. 3 is what kind of fraction? Improper. So if it's improper, it's going to look skinny. That's going to be your stretch, like taking a rubber band and stretching it. Okay? All right. But you don't have to know anything about those shrinking and stretching and all that. You just have to know that if you do your parent function, you take all those y values and you multiply by the coefficient. And that's all you do. All right? I see a lot of, wait until next semester. You'll be,
Just don't
All right.
see why they make these kind of classes that way.
I got the
What?
Ren and Stimpy reference.
That's it. You've had that before. You just forgot about it.
You don't remember Ren and
Girl,
Stimpy?
20-something years ago was like yesterday.
I hated
It was yesterday.
The only thing I picked up from it was the happy.
Now, you are viewing all those. You are viewing those videos, right? Okay. All right. Who said what videos? Who said what videos? Oh my Lord. We've been talking about that. Oh no. I'm sorry. Wrong class. Wrong class.
The only videos we got-
No, you haven't. I'm sorry.
We make.
No, wrong class. But I do have videos for. I guess with the videos you're looking at, the class notes. You do know about the class notes, right?
Mhm.
Okay. All right.
Yeah, sure.
Let me.
The other videos.
All right. So the question is, what are these other videos? Okay, let me give you this. Just remember, I got to tell you what you put with number 4. Take one. Sorry. So when you get number 4, make a note of this. All right, so when you get number 4, I do want you to do shifting here. So you're going to grab the parent function first, right? Grab that first, and then you're going to shift this what?
To
It's on the numbers on the outside.
to
Numbers on the outside. The numbers on the outside is what kind of shift?
vertical.
Vertical. It's a vertical shift. See the square root of x, and then what?
Down to
Subtract 2. So it's a shifting down how many units? 2. Okay, so don't forget to use shifting on this one. The other 3 you can use a t-table. I wouldn't. I would just use the parent function and just remember the y values. That's the way I would do that. But that's not due until Thursday, so I'm sorry, Tuesday.
Yeah.
So Thursday you can have something and then help each other with it.
So this is due Tuesday?
Part C is due
The one
Tuesday.
sheet.
Okay? Part C is due Tuesday. Say it again?
He misspoke. You misspoke a few minutes ago.
I did. So A and B are due when?
Thursday.
Thursday.
And And C is
That's
due
an easy one. C is due
Tuesday.
Tuesday. Okay? All right. And then Thursday, we're going to start talking about the factoring. So we're going to start chapter 6 Thursday. Okay? Now, I think I've done enough to where y'all can start working on my math lab for the new section. So it's not that difficult.
3.6 C is due today.
3.6 what?
C, part C,
Next Tuesday.
next Tuesday. No, 3.6.
Oh, 3.6.
Yeah, I thought y'all turned it in if it was. Let's see.
12.
So according to
3.6.
according to the assignments, the only thing that was due today was
That's due on Thursday. Part C, 3.6 C.
yeah. So today's the 4th. So 3.6 part A B. 3.6 part C is due. So this one's due Thursday. 3.6 part C, and then part A and B of 8.2. Now I have C right here being due. 8.2 C is being due the 6th, but it's not. It's going to be due on the what they would say
And those are worksheets? That's next Tuesday.
the 11th. So how many worksheets are due Thursday? 3. They are 3.6 part C. That it looks like this.
Is there a 3.6 part C?
Yeah.
Yeah.
Yes, I
Must
gave that
not-
out to you last time. That's one of the functions on it. Okay, so that's an easy 10.
I guess I turned it in already.
You
Yeah.
probably did. There were some people that turned it in. And then A and B is what I gave y'all today. All right? Okay, so Thursday, we're going to start chapter 6. That's the one with factoring. So most of what we do now is going to have to deal with factoring. So it's very important to know how to factor. If you struggle with factoring, you don't do anything to help yourself get factoring, the rest of the chapter is going to be a struggle for you. What do you need, man?
Where's your homework stuff?
Okay, so see me after class and I'll get it out checked, okay?